Alright, so now we are going to start section 9.1. So before we do that, we need to identify, this is all about trig identities. Again, this is review. We did this last year, but let's remember. So reciprocal identities, you're basically identifying what is the reciprocal of each of the functions. So the different reciprocal identities. The reciprocal of sine of theta is equal to 1 over cosecant of theta. The reciprocal of cosine of theta is going to be equal to 1 over secant of theta. Now remember, they're not asking for the inverse because we know that the inverse of sine is cosecant. They're asking for the reciprocal identity. So that means you take the inverse and you flip it around. Alright, and then tangent of theta, the reciprocal of that, is 1 over cotangent of theta. Cosecant of theta, the reciprocal is going to be 1 over sine of theta, and that's equal to secant of theta, the reciprocal is equal to 1 over cosine of theta. And then cotangent of theta is equal to 1 over tangent of theta. So the reason why these are important is because you can basically, if you have sine of theta, you can rewrite it as 1 over cosecant of theta if needed. Alright, the quotient identities is exactly what it states. They are identities that use division. So those identities are well known. Tangent of theta, its quotient is going to be sine of theta over cosine of theta. Cotangent of theta, its quotient identity is cosine of theta over sine of theta. Alright? Now the Pythagorean identities, literally you need to think of the Pythagorean theorem. Okay? So the best way to think about this, so on our unit circle, if you make a triangle, alright, remember the Pythagorean theorem is basically if this is A, this is B, and remember that C is always going to be our hypotenuse. Now on the unit circle, so our Pythagorean theorem is A squared plus B squared equals C squared. But on our unit circle, A is represented by sine, cosine, because it's the x variable. So it's cosine of theta, cosine squared of theta, because it is going to be this squared, plus sine squared of theta is equal to the hypotenuse. And remember, on a unit circle, the hypotenuse is always 1, so it's just going to be equal to 1 squared, which is just 1. Alright? Similar, so basically it's the same exact identity, but written using different trig functions. So another Pythagorean identity is 1 plus tangent squared of theta is equal to secant squared of theta. And then the last one is going to be 1 plus cotangent squared of theta is equal to cosecant squared of theta. And remember, you can write these in different ways. So I can move, for example, cosecant squared of theta minus 1 is equal to cotangent of theta. Or I can say that cosine squared of theta is also equal to 1 minus sine squared of theta. And then the last one is the negative number identities, and that deals with negative theta, okay, or negative x. So sine of negative theta is equal to negative sine of theta. Also, cosecant of negative theta is equal to negative cosecant of theta. Oops, cosecant of theta. The same thing happens with tangent. So tangent of negative theta is equal to negative tangent of theta. So I can basically, with these functions, I can just pull the negative out of theta and put it right in front of the whole entire function. And the same thing happens with cotangent of negative theta is equal to negative cotangent of theta. But cosine is a little bit different. So cosine of negative theta is equal to cosine of theta. So if you have a negative here, it actually turns the whole entire trig problem positive. And same thing with secant. So secant of negative theta is equal to secant of theta. So these are the only things that are a little bit different. And you'll see why these are the way they are when we start doing our problems. All right, so keeping these in mind, you need to have these memorized, understood, remembered, whatever you need to do, because if you don't, it's going to be very, very hard to complete the operations using them. So I'm going to keep this literally right next to me when I'm doing these problems. All right, so the first example says perform the indicated operation and simplify the result. So basically, the first thing I see here is that secant is being divided by cosecant plus cosecant is being divided by secant. Looking at all of my identities, specifically the division ones, none of them really match up. So I know I can't use the quotient identities, but I could possibly use the reciprocal identities. But to do that, I need to separate these. So I know that secant of x times 1 over cosecant of x is the same thing as secant over cosecant plus cosecant of x times 1 over secant of x. So now that I have that, the only thing that I could do is basically use my reciprocal identity, and looking back at it, it says that secant is equal to 1 over cosine of x. And 1 over cosecant of x is equal to sine of x. And you'll see why this is important in just a second. And the same thing goes here. Cosecant of x is equal to 1 over sine of x. And 1 over secant of x is equal to cosine of x. Alright? So all I did was I used my trig identities. I just rewrote whatever I had using this. Your goal is to always get things down to kind of sine and cosine, because those are going to be the easiest to simplify. Now look what happens here. So I'm going to bring these back together. So when I do, this becomes sine of x over cosine of x. Plus, bring these back together. This is cosine of x over sine of x. And now I can use my quotient identities. So sine over cosine is equal to tangent. and cosine over sine is equal to cotangent. So here we have tangent of x plus cotangent of x. And that's as far as I can go. I've basically simplified it. I've taken it from 4 trig functions down to 2, and I could, if I try to keep going, all I'm going to do now is just complicate things. So this is as far as it goes, and that is my answer. All right. Number 2. Number 2, we're going to do something very similar. Cosine is where we want it to be. It's still cosine. So I'm going to put cosine of beta, but secant, I'm going to rewrite it using the reciprocal identity, which is 1 over cosine of beta. And then cosecant, I'm going to rewrite it as 1 over sine of beta. And now, when I distribute this to everything, well, remember this is a 1, so when I distribute this, I end up with cosine of beta over cosine of beta plus cosine of beta over sine of beta. So what happens whenever you divide something by itself? It turns into a 1. And we know that cosine of beta over sine of beta, based on my quotient identity, is cotangent of beta. And that is as far as I can take this. Done. All right, let's look at the next examples. All right, so here we have, it gets, a little bit complicated when you have a binomial in the denominator. So basically, what you want to do at this point is you want to get a common denominator so that you are able to combine these into one, because we are trying to simplify, correct? So to get a common denominator, I need to make the denominators the same. So if I look at this, I basically ask myself, okay, what does this denominator need that this guy has? And it's sine of alpha minus 1. And of course, what you do to the bottom, you have to do to the top. And then here, it's missing sine of alpha plus 1. And what you do to the bottom, you have to do to the top. So what we end up with is sine of alpha plus 1 minus sine of alpha minus 1. All of that is now over sine of alpha minus 1 times sine of alpha plus 1. Alright, now you notice how I put parentheses here because this is a minus sign. So this is going to get distributed to everyone up top. And then here what we can do is we have a binomial and another binomial. So what I can do to these guys to simplify them is actually FOIL them. So this becomes sine times sine, which is just, let's do actually the top part first. So sine of alpha plus 1 minus sine of alpha, and then plus 1. And you notice this is going to clean up pretty nicely. And then the bottom portion, when you FOIL this, it becomes sine squared of alpha. That's the first. Outer is plus sine of alpha. Inner minus sine of alpha. And then the last is minus 1. So what do you notice happens to sine of alpha minus sine of alpha? Well, they go away. And then what you're left with is just 1 plus 1, which is just 2. And then down here, what do you notice happens to positive sine of alpha and negative sine of alpha? They cancel out. So what you're left with is sine squared of alpha minus 1. Now I could attempt to stop here, but I know that this looks familiar. This looks like the Pythagorean identities because I have a squared and a 1. So I'm just going to bring back my identities and I'm going to kind of see where do I have sine squared of alpha. And it's obvious that I have sine squared of alpha in this first identity. So I'm going to do a little side job down here. So I know that cosine squared of alpha, or let's do alpha, plus sine squared of alpha equals 1. But here I have sine squared of alpha minus 1. So if I move this 1 over, so I have cosine squared of alpha plus sine squared of alpha minus 1 equals 0. But what do I got to do to that cosine squared of alpha down here? Move it over to this side of the equation. So I subtract cosine squared of alpha from both sides. And what I end up with is sine squared of alpha minus 1 is actually equal to negative cosine squared of alpha. So my final answer for this identity is 2 over negative cosine squared of alpha. And that's it. And it doesn't matter if you put the negative here or here. Alright, next problem. Now for this problem, it's actually easier than it looks. Alright, so the first thing that we have to do is FOIL this out. So remember that 1 plus tan of s squared is the same thing as saying 1 plus tan of s times 1 plus tan of s. And don't forget this minus 2 tan of s. And remember, a lot of these you kind of have to just guess and check your way through. I mean, if I can't do anything with tangent without simplifying it, that's why I just thought of, okay, let's FOIL this, because nothing in my identities looks similar to what I have up here. So now when I FOIL this, I end up with 1 for the first. The outer is plus tan of s, inner plus tan of s, and then the last is plus tan squared of s, and then of course the minus 2 tan of s at the end. Now I'm going to combine my like terms. Alright, so I have 1 plus 2 tan of s plus tan squared of s minus 2 tan of s. And I'm going to continue to combine my like terms. And what happens is that this positive 2 tan of s and this negative 2 tan of s cancel out. So we're left with 1 plus tan squared of s. And again, this looks familiar, correct? It looks like the Pythagorean identities that I've had before. So I'm going to bring back my Pythagorean identities and look at that. It looks exactly like this one. It's 1 plus tan squared of s, or theta, which equals secant of theta. So my final answer is secant squared of theta. Done. Or actually it is supposed to be an s because this problem has an s and not theta, but you get the picture. Okay? Alright, number 5. Okay, you know what, let's do number 5 together in class. This is a harder one, so let's actually do that one together in class. Okay? Alright, let's go to number 6. Number 6 looks very complicated, but it's actually not complicated at all. The first thing I notice here is this. This looks very similar to possibly the Pythagorean identities. So, if I bring over my Pythagorean identities, I see I do have tangent square root of theta and secant square root of theta right here, but it looks a little different. So I need to manipulate it so that it ends up looking like this. So let's do a little bit of a side. So here's my Pythagorean identity. 1 plus tan squared of theta equals secant squared of theta. And basically, I know that I need to get these two things together on one side, and there has to be a minus sign in between them, which is simple. If I subtract tan squared of theta, both sides, I end up with 1 equals secant squared of theta minus tan squared of theta. So, what did we say secant squared of theta minus tan squared of theta is? It is equal to 1. So that's the first thing. Now on this side, okay, on this side, I have cosine. I really don't want to play around with cosine. It's as simple as it gets, but I need to play around with this secant. And I know from my reciprocal identity that cosine of theta is on top. And I'm changing theta because it's easier to just write theta all the time. Over 1 over cosine of theta. I just rewrote secant as 1 over cosine of theta. And then here we have sine of theta, and then cosecant, I'm going to write it as 1 over sine of theta using the reciprocal identity. Now, of course, if you have a fraction, you flip the guy and multiply. You remember that? So cosine of theta times cosine of theta is just going to be cosine squared of theta. And the same thing happens here. Sine of theta times sine of theta over 1 is sine squared of theta, and that equals 1. And then this is actually your Pythagorean identity. And we know that this, based on the Pythagorean identity, does equal 1. So 1 equals 1. And that's how we verify, because these problems are actually asking you to verify that each equation is an actual identity. And that's what I did. I verified that these two sides equal each other. Alright? Alright. Now, I could have stopped here. Okay? Just keep in mind, I could have stopped here because this is an identity. It's the Pythagorean identity. I could have stopped here. I didn't have to go all the way down to 1 equals 1. All right. Nope. All right. I don't seem to have 7 and 8. So it's okay. Let's stop here, and then we will actually complete this together in class.